Hi everyone, and welcome to the Learning Curve Academy. In this video, I will be looking at evaluating complex numbers. In particular, I'll be focusing on complex number problems, which typically feature in advanced courses in mathematics, as well as for students studying mathematics, usually in level 1 at universities in either the social sciences or the natural sciences. In the first problem here, we're asked to express as a complex number 2 minus the square root of -4, and we're given some options here to choose from. So here I'm going to write this problem, 2 minus the square root of -4. We're going to write that as 2 minus, now to evaluate the square root of -4, I'm going to express that as I square root of 4. Keeping in mind that when you're evaluating the square root of a negative number, I is equal to the square root of -1. So the complex number I is equal to the square root of -1. So when you're evaluating the square root of a negative number, it can be re-expressed as I multiplied by the square root of -4, where I is equal to the square root of -1. It's basically pulling out the square root of -1 from under the square root of -4 here. So that's why we can express it as I square root -4. So this therefore becomes 2 minus I, and the square root of -4 is, square root of +4 rather, is 2. So this gives us 2 minus 2 multiplied by I is 2I. So that is how we evaluate the square root of a negative number, by pulling out the negative root and calling it I, and we'll just be multiplying I by the square root of the positive of the number that was under the square root. It's as simple as that. So the answer here is 2 minus 2I, which is option 2. Now for this question, we're given the quotient here, 8 minus I. Remember that I is the complex number square root of -1. So here we're given 8 minus I all upon 2 plus I, and we're asked to express this in the form A minus BI. Okay, so basically we're asked to express this in the standard form. A minus BI or A plus BI is called the standard form of a complex number. So here we say 8 minus I over 2 plus I. To express this in the form A minus BI, what we're going to do is that we're going to multiply both the numerator and denominator of this complex number by the conjugate of the denominator. And the conjugate of the denominator is simply expressing the denominator with the inverse sign for I. So since the expression in the denominator here is 2 plus I, then the conjugate of it would be 2 minus I. If the denominator was 2 minus I, then its conjugate would have been 2 plus I. So we multiply both numerator and denominator here by the conjugate of 2 plus I, which is 2 minus I. So this will be equal to 8 minus I. So we're going to multiply numerator by numerator and denominator by denominator. So it's 8 minus I multiplied by 2 minus I all over 2 plus I multiplied by 2 minus I. So for the numerator, we're going to multiply 8 by 2, which is 16. First term by both terms in the second bracket, and then the second term in the first bracket by both terms in the second bracket. So 8 multiplied by 2 here gives us 16, then 8 multiplied by I gives, by negative I, gives us negative 8I. So what we just did was to multiply the 8 by both terms in the second bracket. Now we're going to repeat that process for the second term in the first bracket, which is multiplying negative I by both terms in the second bracket. So negative I multiplied by 2 will give us negative 2I. then negative I multiplied by negative I will give us positive I squared. Positive I squared. And we're going to divide all of that by, this here we have 2 plus I multiplied by 2 minus I, which is a difference of squares. When you're evaluating difference of squares involving complex numbers, we could just square the constant. We're going to square the constant, which is 2, and that is 4. And then we multiply I by negative I, which is going to be minus I squared. Right? So positive I multiplied by negative I gives us minus I squared. So that is how we can simplify that very easily. So this becomes 16 minus 8I minus 2I is going to give us minus 10I. And now I squared is equal to negative 1. Now that is intuitive, because if I is equal to the square root of 1, then when we square the square root of 1, that is when we raise the square root of 1 to the power of 2, the square root goes, leaving us with negative 1. So I squared is equal to negative 1. So this is going to be plus negative 1. Or I could just go straight ahead and say minus 1. Alright, so minus 1. All divided by 4. Now again, remember that I squared is negative 1. So it's be 4 minus minus 1. I'm replacing the I squared here with negative 1. Further simplifying this, we get 16. We can group like terms here. So 16 minus 1 here is going to be 15 minus 10I. Now don't try to substitute the value of I, which is the square root of negative 1. Never try to do that when you're solving these problems, because it makes the problem more complex. But if you have I squared, you should go ahead and substitute negative 1. Now this becomes 4 plus 1, which is 5, because the negative multiplied by the negative here is going to be positive. So this answer becomes 15. I can re-express this 15 minus 10I all over 5. I can re-express that as 15 divided by 5. Take away 10I also divided by 5. Now 15 divided by 5 gives us 3. And 10I divided by 5 gives us 2I. So the final answer here is 3 minus 2I, which is option number 5. So that's how we solve complex numbers which take the form of a quotient. Now, I to the 5th power, remember that I is equal to negative 1. So I squared rather is equal to negative 1. So I squared is equal to negative 1. So let's look at this. It's I squared. So we're going to use the fact that I squared is equal to negative 1 to find I to the 5th power. That's what we're asked to find. I raised to the 5th power. But what do we know? We know that I squared is equal to negative 1. So if I squared is equal to negative 1, then I squared multiplied by I squared multiplied by I to the 1st power, an invisible 1st power, would be the same as I to the 5th power. Based on the laws of indices, I squared multiplied by I squared multiplied by I to the 1st power, or just I, will be equal to I to the 5th power. Because I'm multiplying terms with the same base, then I just add the powers and keep the base. So 2 plus 2 is 4, plus 1 is 5. So all of this can be expressed as I to the 5th power. So if I can find I squared multiplied by I squared multiplied by I to the 1st power, then it would give me the equivalent of I to the 5th power. So let's try that. We know that I squared is negative 1. So this will be negative 1 multiplied by negative 1 multiplied by I to the 1st power, which is just I. We don't want to try and re-express that because of the fact that I itself is the square root of negative 1. Re-expressing back I in that form will just make the problem too complex. So I to the 5th will be equal to negative 1 multiplied by negative 1 is 1. Negative multiplied by negative is positive. So this will be 1 multiplied by I. So I to the 5th would simply be 1 multiplied by I, which is I. So that's the answer. I raised to the 5th power is simply I. So that's our answer right there. And that is how we take care of that problem. Now moving on to another one. Here we have z equal 2 minus 3i and q equals 4 minus 2i. And we're asked to find zq minus q. Okay? So to evaluate a complex number like this, we're going to say, okay, 2 minus 3i. This will be zq. 2 minus 3i multiplied by 4 minus 2i. This is going to give me zq. So zq, and then we're going to subtract q from that value. So we're going to multiply 2 here by both terms in the second bracket, and then negative 3i by both terms in the second bracket. 2 multiplied by 4 gives us 8. 2 multiplied by negative 2i gives us negative 4i. Now negative 3i multiplied by 4 gives us negative 12i. And negative 3i multiplied by negative 2i gives us positive 6i squared. So this is zq that we're finding. So we can simplify this further as 8 minus 16i plus, since I squared is equal to negative 1, this will be 6 multiplied by negative 1. So this will become 8. 6 multiplied by negative 1 is going to be negative 6. So just group in like terms there. So I will get for zq would give us 2 minus 16i. So what we're going to do now is to take zq minus q, which is going to be 2 minus 16i. Okay, so that's 2 minus 16i. Take away q itself, which is 4 minus 2i. And to solve this problem, what I'm simply going to do is to subtract the real component and then subtract the imaginary components to get the answer. So this is really simple. So it's just going to be 2 minus 4. Yes. Right, so that will be 2 minus 4. That's subtracting the real components here. So complex numbers in standard form of a real component. The 2 and 4 are the real components in both of these numbers. So it will be 2 minus 4 plus, open bracket, negative 16, which is the coefficient of I in the first bracket. Take away negative 2. I'm going to close that bracket, I. So 2 minus 4 here is going to be negative 2. Then this becomes plus negative 16, because negative multiplied by a negative here is going to be positive. So this becomes negative 2 plus, again, negative 16 plus 2 is going to be negative 14, I. So this can simply be expressed as negative 2 minus 14, I, which is option 5. That's the answer. And that is how we simply multiply complex numbers in standard form and subtract complex numbers in standard form, which we executed here. We subtracted the real components and then subtracted the imaginary components. Because I is common to both of these terms, that's why I factored out I here to make it simple. And that's the answer. Finally, we have a complex number here, and we're told that the complex conjugate for this 2 minus 3i upon negative 2 plus 5i. When you are trying to find the complex conjugate of a quotient, of a complex number written as a quotient, you just need to look at the denominator. The denominator here is negative 2i plus 5. And I could rewrite this as 5 minus 2i, yes? This is appropriately now written in the form where we have the real component first. So the conjugate of this would simply be found by changing the sign of the imaginary component, and that would be 5 plus 2i. Of course, 5 plus 2i is the same as 2i plus 5. So when you're writing the conjugate, the complex conjugate of a complex number expressed as a quotient, all you need to do really is to just change the sign of the imaginary component. That is the component, the I component. So the real component is the 5, and the imaginary component here is the negative 2, which is multiplied by I. So by changing that to a positive, because it's negative right here, I get 5 plus 2i, or simply 2i plus 5. The order here does not matter. Right? So the answer is 2i plus 5, which is indeed option 5. So this is complex numbers, evaluating complex numbers. Various types of problems were worked here, and this is how, at a glance, you evaluate complex numbers. There will be further lessons on complex numbers and many other topics in mathematics, statistics, and economics as well. Stay tuned to the Learning Curve, everyone. Remember to like, share, and subscribe. And let's keep our indulgence in the world of mathematics alive. Thank you.